My name is Jack Wren. I work with the state of California, a state agency. My title is security engineer. So initially we thought, oh, okay, great. And somewhat naively, we thought, okay, we're going to solve problems. This is going to be very straightforward, and people will actually track their own certificates. So this couldn't be further from the truth. We ran into a lot of problems where there were a lot of duplicate certificates or duplicate effort. And what ended up happening was that users would request certificates multiple times because there was a pre-production environment, a development environment, a production environment, and they would request these certificates, and then what would happen is that the certificate itself might sit around stale or unused for a while. And then what we discovered also is that users would actually, they would share this information among their coworkers. So, you know, the keys would just be floating around. And it was very hard to track. Everything's on an Excel spreadsheet, and the certificate authority itself has no way of any kind of metadata. You can't track the email address, the group, the telephone information. And then so you're just getting this bigger and bigger Excel spreadsheet. And the spreadsheet is unwieldy. There's no single point of truth. So let's say you have 3 or 4 major groups. Each one wants to have their own spreadsheet. And then we as the security group, we're actually issuing these certificates. We also have our own copy. And then so all of these things quickly get out of whack. When I started the initial PKI build, we were fine with RSA 1024-bit key length. And as the requirements changed, then we enforced a policy which migrated everyone to 2048 or even higher. And now ECC is just around the corner. So SHA-1 is another example. So SHA-1 is a hashing algorithm. We use it on our smart cards. We use it for our certificates. And now we're actually enforcing a policy where all the new certificates are using SHA-2. And so once again, we want to try and be ahead of the curve before we're forced by other vendors or other requirements in the environment and things break. So we want to be ahead of the curve. With our initial deployment of our certificate authorities, we initially thought that we could train the users and they would actually have a product that they would feel comfortable with. You know, we're going to give them best practices and people are going to follow the rules. Well, unfortunately, the typical user actually, they're focused on their own application, and so what they'll do is they will download, for instance, these certificates and keep them in PFX formats and make multiple backups. You know, it's understandable. What they want to do is they want to make sure that they can always get a hold of that key, get a hold of that certificate, and use it in whatever environment they need for their application to reduce downtime. However, this introduced a lot of security possible implications that we didn't anticipate. So they would start backing up these PFX files plus the password for the PFX files on, for instance, a file share where a group can get to them. Or, for instance, multiple engineers would actually have these certificate files just strewn all over the place. So an ideal solution, again, would allow the user to download and consume that certificate at any time, so they don't feel the need that they would have to actually back it up. It's already tracked in the system. The private key is backed up for them, and they can download it any time. They can just create a new PFX file, install it, and the application is running. Or, even better, the system actually will deploy the certificate to the endpoint for the user. So just the act of renewing the certificate will deploy the certificate to the application, restart the application, they're up and running. They don't need to worry about the individual steps in between for the PFX file, the certificate, and so on and so forth. Regarding certificates and security in general, I feel that the certificates themselves and the trust that we place into these certificates is basically a matter of blind faith. And so it's only a matter of time before someone leverages this trust and abuses it. So for example, we just trust these certificate authorities, the certificates themselves, without really considering, like, well, what's the landscape out there? Is someone actually putting code, signing it with a certificate, and just leveraging it on a mobile device or a laptop, or some of these Internet of Things devices? For instance, you might use Nest, you might use PS4, you might use some other kind of console, and these devices all trust certificates. If we're not actively monitoring, checking these devices, mitigating our risk, then these bad actors, they actually can be hacking into things that are in your own home, not just at work, but it could be for the cars, it could be for your consoles, it could be for eventually your thermostat, your alarm system. So we actually have to broaden our overall thinking and our viewpoint, and not just look at, well, I've taken care of certificates I know about, I've taken care of the trust anchors that are at work, but look a little more globally. Think the way a bad actor would. They're looking to monetize any kind of compromise. So where are the holes, and where might they go? So I realized we needed to find a solution where we could have a single point of truth. We can actually work with all of the groups and come up with some kind of system where the certificate itself is tracked. There's information about the certificate, not just the certificate itself. So who's using it? What's the group? In case something happens, who do I contact in order to help them resolve this issue? And ultimately keep uptime and therefore the application running to the absolute maximum. Our goal is absolutely no downtime, and in that case, you want to have these certificates, have this notification system that could also escalate, and someone somewhere can take action, or they're actually using it in order to provide trust where there's no need for it to operate. One of the features we were looking for in this product would be, if there were an issue with one of our certificate authorities, how would we quickly be able to migrate from one platform to another? So we're looking for some kind of automation. Now the automation in this case would be, it would deploy certificates all the way to the endpoint. So without human interaction, you would actually be able to request a certificate, and the certificate would be issued, and the certificate would be deployed to the endpoint, and the service would actually restart, and therefore you have end-to-end product integration. And so in this case, if you actually had a product that could actually do all of these things, then replacing a certificate authority in the case of a compromise would be very quick. We were talking about, in the matter of a few hours, you could actually replace all of these certificates. If we did not have a product like this, we actually calculated just working overtime and having all the engineers working on this, it would probably take us a few weeks. And we couldn't be certain. We actually got all of our certificates replaced, and we've mitigated our risk. The product that we're actually looking for that would fit the ideal scenario is that it would actually be able to keep track of these certificates and give us information about when they're being used and who's actually using them, and go out and actually verify that the certificate is where it should be. There probably is an application that it's tied to. Is that certificate where it should be? Is it showing up in other environments where they shouldn't be, where maybe someone might be abusing the certificate? Initially, there was actually no budget. So the management was not even aware of a need for some kind of enterprise key management. So when I brought up this line item, initially there was some resistance, but with help through a vendor, and also by talking through the individual security points, the vulnerabilities of not actually tracking it, the potential downtime, then management was quickly convinced, and then they were on board. I think I got quite a bit of support in order to put in a new line item where something did not exist before. One of the thoughts was to save the California taxpayers money by actually increasing efficiency and reducing the manpower necessary to manage these certificates. So if there was a way to deploy the certificates from a product all the way to the endpoint and automate these steps, then what we could do is reduce the human interaction and therefore the human hours, the dollars paid for this person to actually manage something like this, and automate it. And this would be a great cost savings. It's a win-win all around.